will you talk about photonic integrated circuits? This is an emerging technology, and the opportunities are immense. Photonic integrated circuits. Okay. So, what are photonic circuits? Photonic circuits are circuits that use light. Okay. So, we know about computer chips, microchips, CPUs, all that. These are microprocessors and various logic gates and all that are etched on silicon wafers, and it works through electrical impulses, right? You have semiconductors that open and close gates and all that. So that's what you typically have in computing, though that's the kind of circuits you have on silicon wafers. Photonic circuits or photonic integrated circuits, like Shri Nair is saying, these are devices that use light. These devices use photons instead of electrons. So instead of using electrical signals, you're using light impulses, light signals, photons, to perform the same functions, various functions like data transmission, signal processing, computation, all that. So that's what a photonic circuit is. So it is the same thing. It is the analog of electronic integrated circuits, but they operate using light. That's what it is. So that's what it is. Now, how do they work? What are the building blocks? What are the fundamental building blocks of photonic circuits? When it comes to electronic circuits, you have silicon, and you have semiconducting material that acts as the logic gates, and you have electricity that passes through this, and it performs various operations, logic gates, and or not, XOR, and so on and so forth. The same thing can be done through photonic circuits. Now, what are the building blocks? You will have, first of all, waveguides. Waveguides are, like, you can think of them as pipes through which light passes. So they confine light and they guide light through specific paths, similar to how wires guide electrical signals. So that's waveguides. They're typically made from materials with high refractive indices. There's something in optics called the refractive index. So you use waveguides. Are made from materials with high refractive indices, such as silicon, or whatever else. Then you have splitters or couplers. So these devices, they will split or combine light signals from different waveguides. You take multiple waveguides and you bring them together, the signals. So this is used for distributing light signals across various paths of the circuits. Then you have modulators, you have detectors, you have resonators, and lasers, and so on. So all of this is what goes into creating a photonic integrated circuit. There are certain advantages that photonic circuits have. First of all, they are faster than your standard electrical circuits, because light travels faster than electrical signals. So photonic integrated circuits will operate at higher speeds. So they are better. They are actually ideal for high speed data transmission and processing. And we already know that we have fiber optics which make use of the same thing. And fiber optics have excellent fidelity and all that. Uh, Now, bandwidth, when it comes to bandwidth, photonic circuits can handle a much higher range of frequencies or wavelengths compared to electronic circuits. So you will have much more data that goes through your circuit. The data throughput is much better than when it comes to electrical circuits. There is heating. When it comes to photonic circuits, these circuits, they generate much less heat compared to electronic circuits, and so on. When it comes to electric circuits, there is there is a lot of the possibility of electronic interference. When you have photonic circuits, they are immune to electromagnetic interference. For example, you need Faraday cages and all that. In the case of photonic circuits, you won't have that, and so on. And there are lots of applications of photonic circuits. For example, telecommunications, you can use them in data centers, you can use them for computing itself. Quantum computing is a very major application of photonic circuits and all that. So that's what you have. That's what you have. Now there are challenges. This is a new technology. How to integrate photonic circuits with existing computational systems, computer systems, electronic systems? How do you do that? That's challenging. So you have to take a photonic signal, light signal, and convert it into an electric signal when you are interfacing a photonic based device with an electronic device. Manufacturing is difficult. There is a lot of complexity, and you need a lot of precision. These are all engineering challenges which will eventually be overcome. That's where we are. And then there will be limitations of various materials. It depends on the kind of materials you're using and how good those materials are. So finding materials that are efficient as well as compatible with existing semiconductor manufacturing processes is a challenge, and so on and so forth. So it's an emerging technology, and it's going to eventually become a big deal. And we are already transitioning towards that, especially when it comes to things like quantum computing, etc. So that is what photonic integrated circuits are. It is something that can work actually better than the electronic microprocessors and electronic circuits that we have in use today in all our devices, whether it's a phone, a laptop, or whatever. It is something that will eventually be a much better, much more robust, much more powerful technology. There'll be very less heating. It'll be much faster. So it makes sense to invest in the development of this technology. And like you say, the opportunities are immense.